This is a Curiox HT-2000. It's a laminar flow cell washer. We recommend it for using as an alternative to centrifuge-based washing when processing cells for flow cytometry or sequencing. But it has some really great advantages. It is a standardized procedure. It reduces the stress on your cells, saves time and antibody. It can increase the number of cells that are retained after processing, increase in viability, and decrease the amount of debris present in your sample. It's really great for messy tissues like kidney or liver, samples that typically have a lot of debris present. So before you get started with the Curiox, you're going to need to purchase a plate, and a buffer cap with tubing, which is present here. So generally, I will start up the instrument, and it should be ready for you to use when you get to the lab. But if I am not here, or if you're working after hours, the first thing you do is turn the instrument on. The switch is in the back. The tray will extend, and the first thing we need to do is we're going to make sure that the inlet tubing is connected to the ethanol with tween. We're going to load our dummy plate into the tray. We're going to go to the service mode, and page 2 of service, we're going to do a standard prime with ethanol. Once the standard prime is finished, we remove the dummy plate, dump it in the sink, replace it, move the inlet tubing from the ethanol and tween to the water and tween. Press OK. We're going to do another standard prime with water and tween. All right, once the standard prime is complete with the tween and water, I'm going to remove the dummy plate. Once again, dump it in the sink. The next step is to calibrate the instrument to make sure that it's dispensing properly. We're going to load the calibration plate, and we're going to dispense 80 microliters, which is this button here. Now we remove the plate and inspect it to make sure that all the wells are evenly filled and that the dispensing is working properly. Then we put it back on, and we're going to go to operation mode, and we're going to set it at flow rate of 10 microliters per second. Our volume, initial volume, is what is in the well, which is 80 microliters. And we're going to wash 4 times. When this cycle is complete, there should be 25 microliters remaining in the wells. Right. Once the wash cycle is completed, we again remove the plate and check to make sure that the volume is even in all the wells. Then we dump the calibration plate. And just a little bit about the laminar wash plate. You can see it has a much smaller volume than most 96 well plates. The maximum volume is 80 microliters. There's a hydrophilic coating in the bottom of the well and a hydrophobic barrier which maintains the droplet inside the well. I would recommend on the back of the plate marking the A1, which is this corner, with a Sharpie. And also mark wells on the back of the plate with a Sharpie that you have already used or that you are using for your current experiment. The plate can be rinsed with DI water after use, and the wells that were not used for one experiment can be used for the next. Just rinse with DI water and store. The maximum volume is 80 microliters. If you need to stain in greater than 80 microliters, you will need to use the large volume adapter. So now that the instrument is primed and calibrated, the next thing is to add your samples to the plate. So when you add your samples, you can add up to 10 million cells per well, and you'll want to pipette it carefully into the center of each well, not in the satellite areas. Then add your antibodies, and if the volume is 50 microliters or less, you can use the shaker to mix, and we'll demonstrate how the shaker works. If you're using more than 50 microliters, you will need to mix by pipetting up and down. Just turn the switch on and just shake for a few seconds. Once you have your cells and antibodies in your plate, incubate a sufficient amount of time for your antibodies to bind and your cells to settle to the bottom of the well. The settling time is sample type dependent and will need to be optimized. So the first time you run an experiment, check every 10 to 15 minutes under the inverted microscope to see at what time point the cells are on the bottom of the plate. So you put your plate away to incubate, and then the next step is to prime the instrument with your buffer that you will be washing with. So at this time, about 10 minutes before your incubation is over, you're going to switch the inlet tubing from the water to your buffer. We recommend that if you're staining your samples at 4 degrees, that you keep your buffer cold. Please bring plenty of buffer, at least half a liter, because when you prime, 175 microliters is used up for a standard prime, and each wash cycle consumes 6 ml of buffer. So be sure and bring plenty of buffer. If you need different types of buffers, bring all of your buffers. All right, once the inlet tubing is attached to your buffer of choice, we will go to the service mode and we will do a standard prime. Oops, don't forget the dummy plate. Dummy plate, standard prime. Once the buffer is primed, your wash buffer, click OK and empty the dummy plate in the sink. When your sample is ready to wash, you will remove it from its incubation and place it on the tray, being very careful not to disrupt the cells, which should be settled on the bottom. So it's given that you do not want to shake this once you're ready to wash. And to wash, we're going to go to operation mode. Now you have 3 settings: the flow rate, the initial volume, and the number of washes. So the flow rate, 5 microliters per second would be a very gentle wash, and if you had a lot of debris, you might want to do more washes. The initial volume is the volume that is in the well right now. So we're going to set this to 50, which is what we have in the well. The number of washes is again sample dependent. 5 washes is a quick wash. 12 is good for moderate antibody-based wash. 24 washes is an extensive wash and recommended for oligo-tagged cells. If you're using 12 or more antibodies, 15 washes is recommended. And it's a good idea to contact your Curiox application scientist for recommended settings for your particular sample type. So we're going to leave this just like this, and now we are ready to wash. And you may have multiple wash steps, multiple buffers, but each time you will choose the appropriate wash settings. While your sample is incubating, maybe you have a second wash, and the buffer in the instrument may warm up to room temperature. Then you can go to service mode and do a head prime, which just replaces the buffer in the head. Once your sample has been washed and you're ready to transfer it to a tube or a well plate, first we'll put on the shaker, shake for a few seconds. We're going to do this in 3 steps. First, we're going to take 25 microliters out of the well, moving the pipette tip all around. Put that in the tube. Add another 25 microliters. Shake. Remove from the well 25 microliters. Place that in the tube. And then repeat one more time. Add 25 microliters. Shake. And take all the volume out of the well. You now should have 75 microliters in your tube or well, and you can add however much more buffer you need to run on the Cytec. The Fortessa, the minimum volume on the Fortessa is, either one is about 300 microliters, and that's transferring to a tube. Down the instrument, you need to remove the inlet tubing from your buffer back to the water with tween. Load the dummy plate. Go to service mode, page 2, standard prime. Right, once the tween water prime is done, then we're going to empty the dummy plate, load it on the tray, move the inlet tubing to the ethanol tween, and this time it's going to be a little bit different. We're going to raise the hood and push this little support bar towards the back so that it stays open. We're going to do the standard prime again, but this time we're going to stop it once the head is primed full of ethanol. Hit the standard prime, and the top portion is going to go up and down 5 times. So that's 1, 2, 3, 4, 5. Now the bottom part is going to start moving. It's going to go down and up 3 times. 1, 2. On the 3rd time, we will stop it. And we're going to stop right there. And then we hit recover. The plate comes out. Once again, dump it in the sink. And the instrument is ready to shut down. So now we can just turn it off with the switch in the back. Once it's off, you can retract the tray manually, release the support bar, and we are all done. Okay. A few troubleshooting tips. If at any time your plate gets stuck, you can just hit stop, and that will stop the process, and then you can have the plate eject. Also, when you run the calibration, if some of the wells do not dispense properly, and either they don't aspirate or they don't dispense, and just note those wells and avoid them, and let Robbie know, and I will take care of it. I'm going to demonstrate the use of the large volume adapter, which you would use if you need to stain in greater than 80 microliters. So I'm going to add 25 microliters to the well. And so you want to have some in the well before you place the large volume adapter on top of it fits inside the frame of the plate. And now I'm going to add 75 microliters for a total of 100 microliters. So you would allow it to incubate with the large volume adapter in place. And after incubation and before the wash, you will remove the large volume adapter. Your cells should all be at the bottom of the well, but it will remove any excess volume above 80 microliters. So when I remove this, there should be 80 microliters left behind. And that is how you use the large volume adapter.